You ever see a self-driving car and wonder how it spots a pedestrian, a stop sign, and another car all at the same time in like a split second? For the longest time, that kind of thing was just science fiction. Computers were way too slow. Well, today, we're going to talk about the one big idea that changed everything.
I mean, really, how is that possible? How does a machine look at a totally chaotic scene and just get it instantly? And we're not just talking about spotting one thing. We're talking about finding and identifying tons of different objects, all overlapping, all at once. For years, this was the great white whale of computer vision. And the answer, when it finally dropped back in 2015, had a name that perfectly captured the genius of the idea. YOLO, as in, you only look once. It wasn't just a tweak, it was a total rethink of the entire problem. And man, it kicked off a revolution in how machines see our world.
So to really get why YOLO was such a massive deal, you gotta understand how things worked before. And trust me, it was a slow, clunky, two-step process.
Okay, the difference here is just night and day. The old way, with models like RCNN, was kind of crazy. First, the computer would guess thousands of different spots in an image where an object might be. Then it would run a totally separate check on every single one of those spots. It worked, sure, but it was painfully inefficient. YOLO just threw all that out. One look, one network, one pass, and you get everything. Done. All right, let's get into that first version, YOLO V1. This thing wasn't just an improvement, it completely tore up the rulebook on how computers could see. So here's the secret sauce. YOLO turned object detection from a classification task into what's called a regression problem. Now, what does that mean in plain English? Well, instead of asking, is this little box a car? How about this one? This one? Thousands of times, it just trained a network to look at the whole picture and spit out the coordinates and the identity of every object, all in one go. And here's how that magic actually happens. You take the image and you just chop it up into a simple grid. Now, each little square in that grid is responsible for one job, figuring out if the center of an object is inside it, and if it is, drawing a box around it and saying what it is. A single powerful brain, a convolutional neural network, does all of this for the entire image in one shot. It's simple, it's elegant, and it is blazing fast. Now, of course, version 1 wasn't perfect, not by a long shot. Because each grid cell was doing a lot of work, it really struggled with tiny objects that were all bunched up, like a flock of birds. It also wasn't quite as precise at drawing the boxes as the old, slower methods. But, and this is the important part, it proved that real-time detection wasn't just a dream. The door was officially open. And once that door was open, the race was on. The next few years were all about making YOLO not just fast, but also deadly accurate and way more versatile. And that brings us to versions 2 and 3. This table breaks it down nicely. YOLO V2, which was also called YOLO 90,000, brought in anchor boxes, basically a set of predefined box shapes to help it get better at detecting things that aren't perfect squares. It also used this wild hierarchical system to learn over 9,000 different kinds of objects. Then YOLO V3 came along and tackled the problem of size. It made predictions at 3 different scales, so it could spot a tiny mouse and a huge bus in the same image. Plus, it upgraded its core engine to a much more powerful backbone called DarkNet 53, which just found the perfect sweet spot between speed and accuracy. Okay, by the time we get to 2020 and YOLO V4, we're seeing another massive leap. This wasn't just about making small improvements anymore. This was about creating a whole new, standardized blueprint for what a modern detector should look like. And the key here is this 3-part structure. Think of it like a factory assembly line. First, you have the backbone, which is like the eyes of the system, extracting all the important visual features. Then you have the neck, which is brilliant. It takes features from different parts of the backbone and mixes them together, so the model can see both the fine-grained details and the big picture at the same time. Finally, you have the head, which takes all that refined information and makes the final call on what's where. This modular design was the real game changer here. It turned building detectors into playing with Legos, letting researchers everywhere swap parts to find the absolute best combinations. What really made YOLO 4 so dominant was this clever cocktail of optimizations that the creators called the bag of freebies and the bag of specials. The freebies were smart tricks you could use during training, like stitching 4 images together into a mosaic that made the final model way more accurate without slowing it down one bit. A free lunch. The specials were new modules that cost a tiny bit of processing power but gave you a massive jump in accuracy. It was this perfect balance that pushed it to the top. So from YOLO V4 on, the whole game started to change. Yeah, accuracy is always important, but the new obsession became efficiency, making these models faster, smaller, and easier to run on literally everything, from a massive server to the phone in your pocket.
And man, you can just see how fast things started moving. YOLO V5 came out right after V4, and it was all about being user-friendly, super easy for any developer to pick up and use. Then V7 and V8 made these huge leaps in training efficiency and smart design, even getting rid of those anchor boxes we talked about for more flexibility. And that brings us to this year, and YOLO V10, which introduces something that is, frankly, a huge deal. It's called NMS free detection. So for the longest time, YOLO models would draw a bunch of overlapping boxes for the same object, right? And then you needed this annoying cleanup step called non-maximum suppression, or NMS, to pick the best one. It was a bottleneck. Well, YOLO V10 cleverly figures out how to avoid that mess entirely during training. By getting rid of that step, the whole process gets faster and simpler, pushing us closer than ever to a true end-to-end detection system. So there you have it. In less than a decade, YOLO went from being this wild idea in a research paper to the absolute gold standard for the entire industry. It's just this incredible story of a brilliant concept that an entire global community has kept sharpening, refining, and pushing to its absolute limits. This whole journey gave computers the gift of sight in real time. But as the latest versions, like YOLO V10, remove the very last hurdles between seeing something and understanding it, you have to ask yourself, what's next? What happens when a machine's perception isn't just fast, but completely instantaneous?